Sunetra Gupta, Breaking Boundaries in Epidemiology by Lyra Alonso. Dr. Gupta's Path in Science. Dr. Gupta was born in Calcutta, India, March 15, 1965. She spent a few years in Ethiopia and Zambia, where she began writing after being introduced by her history professor father, to a Bengali poet. At the age of 14, Dr. Gupta became interested in mathematics, physics, and science. She found science to be poetic, bringing together her feelings on science and the arts. She attended Princeton University, where she received her bachelor's. She later received her PhD from Imperial College, London. Some of the obstacles that Dr. Gupta faced were her father and the rest of her family pushing her towards writing and the arts instead of science. Recently, an obstacle she has faced are the criticisms of her opinions on the quarantines during the COVID-19 pandemic. Hobbies. She herself has said that her hobby is her work. She finds joy in doing her science and getting her work out there. Another hobby of hers is writing. Even after becoming a professor of theoretical epidemiology, she wrote and published 5 books that are, in a way, separate from her work. My connection. I admire her work in epidemiology because it is something I have always wanted to do. My personal goal is to do what Dr. Gupta is doing, to study all infectious diseases. I identify on a personal level with Dr. Gupta's life as a scientist. She is a woman of color, just as I am. Science, though less now, has been led by white men. Breaking through those barriers is something I truly admire about Dr. Gupta. Specific focus. Dr. Gupta is focused on infectious diseases and, in particular, influenza vaccinations. Influenza is more of a danger than most think, with between 294,000 and 518,000 people losing their lives to it every year worldwide. The main question Dr. Gupta focuses on is creating a universal vaccine for influenza. Most recent research. Her latest article is called Fatal COVID-19 Outcomes Are Associated with an Antibody Response Targeting Epitopes Shared with Endemic Coronaviruses. For Figure A, indirect ELISAs analyzed responses to NTD. Fold changes were determined with the average value in the SARS-CoV-2 antibody negative blood donor group was shown in the gray division. For Part B, a correlation in response between SARS-CoV-2 antigens and HCoV OC43 spike protein domains and nucleocapsid were shown in a linear fit model using a log scale. Part C shows a positive correlation between the S2 subunit response and the HCoV OC43 and HCoV HCU1 spike response seen in the fatal COVID-19 group. A t-test and P and R2 values were calculated for significance. The figure displays a result of a strong correlation between fatal outcomes and antibody responses to the HCoV OC43 S2 subunit and the SARS-CoV-2 spike, with a p-value of 6.84 times 10 to the negative 7. Next steps. Among the many discoveries related to disease transmission, especially during COVID-19, she also invented a new method that produces a universal influenza vaccine. This could mean a single lifetime vaccine instead of a yearly vaccine, or a lower death rate, as the body already has antibodies catered to all influenza. Dr. Gupta's next steps are to continue to work on the universal influenza vaccine and any other infectious diseases that begin to impact people. Thank you for watching.